So let us continue. Then our next problem is, that is from the trapezoidal method. Let us see the problem number 2. So we will calculate the by trapezoidal method. So we have seen the problem number 1. Example number 1 we have seen. Now just problem number 2. Here, when divisions are made with unequal interval. Suppose when the divisions are made with unequal interval, the following offsets were taken from the survey line to a hedge, that is distance in meters and offsets in meters. So the distance is 0 to 10, 20, 30, 40, 60, 80, 110, 140. So these are the unequal intervals which are given, and the offsets are 9.8, 10.9, 14.1, 13.1, 8.6, 7.8, 7.0, 6.0, 4.9. So can you observe here the difference of any intervals? Yes. So 0 to 10 the difference is 10. 10 to 20 difference is 10. 20 to 30 difference is 10. Whereas 30 to 40 difference is 10. But 40 to 60 the difference is 20. And 60 to 80 the difference is 20. But coming to the 80 to 110 the difference is 30. 110 to 140 difference is 30. So that means, why we are saying unequal interval means, now here we are having 3 unequal intervals. One is 10, 20 and 30. So find the area between the survey line and hedge by trapezoidal method. So solution, let us calculate this one. In this problem, it is observed that interval between the offsets is not uniform throughout. So we have observed that here the intervals are between the offsets is not uniform throughout the length. That means the unequal intervals are changed. So the survey line may be divided into different sections of uniform intervals. So this survey line, it will be divided into different sections of different uniform intervals. The area of each section may be calculated and added to get total area. So here the area of each section will be calculated and they will be added to get the total area. So let us see here, the survey line may be divided into 3 sections. The first one having 10 meters interval, what we have observed here. So from 0 to 10, 10 to 20, 20, 30, 30, 40 we are having the up to here we have 10 meters interval. Whereas from 40 to 80 we have 20 meters difference. And from again 80 to 140 we have the difference of 30. So like this we have to mention clearly. And here the 10 meters is called A1. Okay, the second one having 20 meters interval, that is A2, and the third one having 30 meters interval, that is called A3. So we have to make it into the 3 parts: area 1, area 2 and area 3. Let us see here, let the areas be A1, A2, A3 and the total area be capital A. So all these A1, A2, A3 will become the capital area A. So the offsets are also given in meters and distance which is taken in meters. It is the chainage. 0 to 10, 10 to 20 and up to it is taken up to the 140 meters length of chain. So the offsets are taken here 9.8, 10.9, 140.1 up to 4.9. So how many offsets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 offsets are there. So let us see here A1 is equal to, substitute in the formula, that is the 10 is D. So this is the formula, D into, that is 9.8 plus 8.6. What is 9.8? That is sum of first placed last ordinate. So that is sum of, we will write O0 plus of O, ON by 2. Okay, plus another ordinates, other offsets. So that is equal to, you will get area, that is D is 10. So 9.8 plus 8.6 by 2. This is 9.8 plus here 9.8 plus 8.6 by 2. Okay, and the other ordinates are 10.9 plus 14.1 plus 13.1. Is it? So we will get the area 473 meters square. So why we are doing like this means because it is the 10-meter interval. The distance between the intervals are D is equal to 10 meters. So that's why we have to calculate separately for equal intervals. And next is A2. So now A2, the D distance of intervals is equal to 20 meters. So that is, here we have to take 8.6 plus up to where it is there 80, 7.0 by 2. Okay, 8.6 plus 7.0 by 2 plus what is the remaining one pending here? 7.8. So you write that one. Then we will get 312.0 mm square. Sorry, meter square. So this is the area of A2. So this is the length area here. And the next is A3. So the A3 also, the here the interval is D is equal to 30 meters. So now let us see 7.0 plus 4.9 by 2 plus of 6.0. So that is this one, 80 to 140. So again 7.0 plus 4.9 by 2. The remaining is plus 6.0. So we will get 358.50 meters square. So this is the A1, A2, A3 areas. So meanwhile, like this unequal lengths it has given, unequal types only, these type also will be there. In unequal chain age intervals, this type of calculation should be done. So now we have got A1, A2, A3. Now we have to calculate total area. A is equal to A1 plus A2 plus A3, that is 473 plus 312 plus 358.5 is equal to 1143.5 meters square. So this is our total area. So like this we have to do the unequal intervals problem. So finally, in this season we have discussed calculating the irregular shaped areas by trapezoidal method. So now next method we are going to see, that is Simpsons rule method. So let us see the another topic, that is calculation of land areas by analytical method of Simpsons rule. Objectives: on completion of this period you would be able to calculate of irregular areas by Simpsons rule, that is analytical method. So once we recap, that is in the last session we discussed, that is calculating area of irregular boundaries by trapezoidal method and solved examples on trapezoidal method. So now let us see the Simpsons method. So these all methods are used for calculating the irregular areas. So this is more accurate method than trapezoidal method. So the first method we have seen, average ordered rule method, and after that trapezoidal method. So here one by one method is more accurate than one another method. So in Simpsons method, the degree of precision can be increased by increasing. So here the degree of precision can be increased by increasing number of ordinates. So the precision can be increasing by increasing the number of ordinates. So this rule assumes that the boundaries between the ends of ordinates are parabolic arcs. So here this rule assumes that the boundaries between the ends of ordinates are parabolic arcs. So here you can see now this is a curve and this is a boundary line. So these are parabolic curves, and as usually this is our baseline. And this is the length of the chain line. So O0, O1, O2, etc. are the ordinates at each of the division, and L is the length of the baseline, and N is the number of equal parts into which it is divided. So the number of equal parts which it is divided. See here, to calculate the area, so this is a formula. So A is equal to D by 3, that is the interval of the offsets divided D by 3 into O0 plus On. Where is O plus On? So this is O0 plus On, that is sum of first ordinate plus last ordinate plus 4 into O1 plus O3. So here we have to take O1 plus O3. You write here O4, O5, O6, O7, O8, O9, and this is O10. So we are having totally 10 offsets. So now we are taking here first is again O0 plus On, that is O0 plus of On, the first ordinate plus last ordinate, into 4 into O1 plus O3. So we have to take 1 and 1 plus sum of plus odd ordinates. Okay, so here O1 plus O3, again O3 plus O5, O5 plus O7, O7 plus O9. Okay, again place the remaining ordinates which are there, that is O2 plus O4 and O6 plus OH is equal to D is equal to interval. So this, in this way we have to take that. So here there is nothing but D by 3 into sum of first plus last ordinate plus 4 into the sum of odd ordinates plus 2 into even ordinates. That is equal to O0 plus On is first and last ordinates, and O1, O3, O5 are remaining even ordinates, and O2, O4, O6 are remaining odd number of ordinates. So in this way we have to take the ordinates compulsory. So here let us see this rule is applicable to odd number of ordinates only. So if there are even number of ordinates, then the area of last division may be calculated separately and added. So if there are even number of ordinates, then the area of last division may be calculated separately and added. So this method is applicable only when interval between successive ordinates is same. So this will be there when this method is applicable only when interval between the successive ordinates is same. So if the interval is not same, the baseline should be divided into different sections, that is each having uniform interval. So procedure to calculate area by Simpsons rule. So observe the interval between the offsets and number of offsets. So first we have to observe the offsets between the intervals and number of offsets, how many are there. And next, if they are regular throughout, find the total area by applying formula only for odd number of ordinates. If they are not regular, the baseline may be divided into different sections of equal interval and compute the areas of each section and add to get total data. So this type of condition we have to do. If they are not regular, the baseline may be divided into different sections of equal interval and compute the areas of each section and add to get total data. So let us see the example 1. The following offsets were taken at 30 meters interval from a baseline to an irregular boundary line, that is 5.9, 12.4, 16.5, 15.3, 18.4, 20.9, 24.2, 21.8, 19.2 meters. So calculate the area enclosed by Simpsons rule. So for every offset, interval is 30 meters. So let us see, given ordinates are, so these are the ordinates, and it is observed that number of ordinates are 9 odd number. Let us count here, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 ordinates are there. So apply formula directly, given d is equal to 30 meters. So O0 is equal to first ordinate 5.9. On is equal to last ordinate 19.2. So first ordinate plus last ordinate. So this is 5.9, 12.4, 16.5. So even number of ordinates in blue, odd number of ordinates are in red. So he has given the colors. So for even number of ordinates is blue, odd number of ordinates is red. So let us see the applying the formula. That is applying formula, A is equal to d by 3 into O0 plus On plus 4 into sigma E1 plus 2 into sigma R. So d is 30 by 3. First ordinate is 5.9 plus last ordinate 19.2 plus 4 into 12.4 plus 15.3 plus 20.9 and the plus 21.8 and plus 2 into 16.5, 18.4, 24.2. This is the odd ordinate. Okay. So these are the first even ordinates in blue, and the odd ordinates are in red color. So then after we will get the area is 4249 meters square. So this is the formula for calculation of Simpsons rule. So simple formula we have to keep in mind. And the example number 2, if the series of offsets were taken at 10 meters interval in the following order from a chain line to a curved boundary, so that is 0, 7.2, 5.4, 6.0, 6.8, 7.4, 8.2, 0 meters. So find the area between the chain line and the curved line by Simpsons rule. So number of ordinates are 8 even. Applying the formula for odd numbers only. So that is apply the formula for first 7 coordinates. Area of last division is computed separately and added. That is, given coordinates are 0, 7.2, 5.4, 6.0, 6.8, 7.4, 8.2 and 0 meters. So here up to here this is A1 and A2. So A1 is equal to, so the odd intervals between these ordinates is 10 by 3 into 0 plus 8.2. First ordinate plus last ordinate plus 4 into even ordinate 7.2 plus 6 plus 7.4 plus 2 into odd ordinates, that is 5.4 plus 6.8. That is equal to 393.33 meters square. So this is the area 1. And area 2, A2 is equal to 1 by 2 into, that is 8.2 plus 0 into 10 is equal to 41 meters square. So here only 1 is there, that is 8.2 plus 0. And A is equal to A1 plus A2 is equal to 383 plus 44 plus 41 is equal to 424.33 meters square. So this is a Simpsons rule, very accurate method comparing with average ordinate method and trapezoidal method. So this is the condition here. Then see the next example number 3. The following offsets are taken from a servo line to a hedge. So this is distance in meters and offsets in meters. So find the area by Simpsons rule. Solution. The baseline is divided into 3 sections because the interval is different. Note that each section has odd number of coordinates. Therefore, Simpsons rule can be directly applied separately for each section. So that is, so let us see here, from 0 to 20 and 20 to 40, 40 to 60 we have 20 meters distance, and from 80 to 120, 120 to 160, 160 to 200 we have the difference between them, and A3 also we have the difference. So A1 is equal to, so we have the differences of unequal intervals. So up to A1 it is 10 meters, and in A2 it is 40 meters difference. This is 10, 40, and in A3 the 30 meters. So here A1 you take 20 by 3 because this is the interval, D is the interval, the first one. Then into the first offset 12, the last offset here 4. 12 plus 4 plus 4 into 10 plus 6 plus 2 into 8. That is equal to 640 meters square. Meanwhile, A2 is equal to the distance between the ordinate seats 40. So 40 by 3 plus here again 4 plus 10 plus 4 into 5 plus 8 plus 2 into 7. We will get 1066.67 meters square. Then again last A3, the difference between the ordinates is 30. 30 by 3 into 10 plus 13 plus 4 into 11 is equal to 670 meters square. So these are the A1, A2 areas which are calculated by the Simpsons rule. So this method is very important for the examinations. So finally, total area A is equal to 640 plus 10.61 plus 670 is equal to 2376.67 meters square is the area. So now let us see the more examples. Let us see some more examples. So now the following perpendicular offsets were taken at 10 meters interval from a servo line to a irregular boundary line. So note these readings: 4.21, 3.5, 3.52, 3.26, 2.48, 2.73, 3.28, 3.72, 4.08, 4.22. So these are the perpendicular offset points which are taken at 10 meters interval. So calculate the area in square meters enclosed between the survey. So by different methods: average order method, Simpsons method, and trapezoidal method. So these methods are used vary in the calculation of boundaries and areas, plots, everything. Solution: average ordinate method, given data. So interval between the offsets is equal to 10 meters. Number of intervals is equal to h. So therefore L is equal to 10 into 8 is equal to 80 meters. So area is equal to sigma O into L by n plus 1. So sigma O we have to calculate, that is 4.21 plus 3.52 plus 3.26 plus 2.48 plus 2.73 plus 3.28 plus 3.72 plus 4.08 plus 4.22. So we should add these all things, then we will get sigma O is equal to 13.50. Then area is equal to L sigma O, which we got 13.5 into L is 80 by 9, that is 280 square meters. So area is 280 square meters. Now next we have to calculate by the trapezoidal method. So area is equal to D into O0 plus On by 2 plus of O1 plus O2 plus of On minus 1. Therefore interval is equal to 10 meters. Area is equal to D into O0 plus O8 by 2 plus O1 plus O2 plus of O7. So why we are taking O7? Let us count here how many ordinates are there. So we can see 1, 2, 3, 4, 5, 6, 7, 8, 9. We are having 9 ordinates. So taking in the trapezoidal method, the first ordinate will be the 4.21 and the next will be the 4.22. So here you can see area is equal to, so that is 10 into 4.21 plus 4.22 by 2 plus 3.52 plus 3.26 plus 2.48 plus 2.78 plus 3.28 plus 3.72 plus 4.08 is equal to 272.85 square meters. So this is the calculation of trapezoidal method. And the next one is Simpsons method. So in the Simpsons method, the area is equal to width of strip by 3 into sum of first and last ordinates plus 2 into sum of ordinates plus 4 into sum of even ordinates. So here the width of strip is by 3, that is A is equal to D by 3 into O0 plus On plus 4 into O1 plus O3 plus O5 like that, and plus 2 into O2 plus O4 plus of n. So this is the Simpsons method formula. So width of strip is equal to 10 meters and number of ordinates are 9, therefore rule can be directly applied. So there are directly 9 ordinates are there, we can apply directly the formula. So let us see here, A is equal to D by 3 into O0 plus O8 plus of 4 into O1 plus O3 plus O5 plus O7 plus 2 into O2 plus O4 plus O6. So this is the area to calculate in the simplest method formula. So that is equal to 10 by 3, which is given 10 meters interval for all. So 10 by 3 into 4.21, which is first ordinate plus last ordinate, plus 2 into 3.26, 2.73 plus 3.72, okay, plus 4 into this written wrong, anyway, plus 4 into, so this is O1, 3.52 plus 2.48 plus 3.28 plus 4.08, then we will get 270.97 square meters. So this is the area of Simpsons method. So now let us see an example 2. The following offsets were taken from a server line to a hedge. So distance 0, 5, 10, 15 to 70, and offsets are 329, 4.05, 623, 5.75, 4.76, 526, 4.32, 3.92, 2.91. So these are the offsets which are given in meters. So find the area between the server line and hedge by Trapezoidal Rule and Simpsons Rule. So these type of problems are very important. They will be asking in the examination also. So the widths of strips are not uniform. Hence we shall divide the area into 3 sections, so that each section has strips of equal width. So section 1 is from chain edge 0 to 20 meters with 5 meters wide strips. So that is the chain edge of 0 to 20 meters. And section 2 is from chain edge 20 to 40 meters with 10 meters wide strips. And section 3 we will have chain edge from 40 to 70 meters with 15 meters wide strips. So now by trapezoidal rule, A is equal to area of section is equal to D into sum of first and last ordinates by 2 plus sum of remaining ordinates. That is area of section 1 is equal to so 0 to 20 meters is 5 meters interval. So that's why here 5 into 3.29 plus 4.76 by 2 plus 4.75 plus 6.23 plus 5.75 is equal to 100.275 meters square. Then area of section 2 is 10 into 4.76 plus 4.32 by 2 plus 5.26 is equal to 98 meters square. Then area of section 3 is equal to 15 into 4.32 plus 2.91 plus 2 plus 3.9 is equal to 113.025 meters square. So the total area is equal to 100.2575 plus 98 plus 113.025. This is equal to, we will get 311.300 meters square. So this is a method of calculating the trapezoidal. Then comparison between Simpsons rule and trapezoidal method. So the results obtained from Simpsons rule are more accurate. For irregularly shaped figures, the degree of precision of either method can be increased by increasing the number of ordinates. So finally, summary. In this session, we have learned that solving the problems by Simpsons method. So in the previous classes, we have seen the average ordinate method, trapezoidal method. So these methods are used for the calculation of areas in the field. So that's why irregularly shaped figures also can be calculated with the help of these 3 methods. So this is the topics regarding the change survey. So thank you. Have a nice day.